Yes. All right. So welcome, everyone. If this is your first Database Tycoon summer camp session, so excited to have you. If you've been here before, welcome. Everyone, I see you've attended every single one. Kudos to you. So yeah, today we're going to be learning about data orchestration from the wonderful Avishua, who used to be an engineer here at Database Tycoon and is now at Wikimedia. And for those of you who it's your first time joining, it's going to be about an hour-ish workshop presentation from Avishua. And if you guys have questions during the workshop, feel free to just write them in the chat, and then we'll have like time for a Q&A afterwards. And if you don't know about Database Tycoon, we're a full stack data consultancy, primarily advocating for open source tools, but also ultimately working across the industry with different tools to build custom data stacks and consult for a variety of different industries. And so with that, I shall pass it over to Avishua. You can begin.
Hey everyone, thank you all for joining for my presentation of Data Orchestration 101. And thank you to Stephen, Chloe, the Database Tycoon team for having me and for putting on these awesome sessions. Let's get into it. So, who am I? My name is Avishua. I live in Brooklyn. I work at the Wikimedia Foundation, the nonprofit that runs Wikipedia, among other projects. I've been doing this data thing for 7-ish years now, 7 or 8. So getting into it, what are we going to cover today? First, what are orchestrators in the concept of data orchestration and analytics, not music or conductors? We're going to go over a real data pipeline I built that uses a data load tool to load data from an API, dbt to transform that data, Google Sheets as my interface to interact with it, and Dagster as the orchestrator running everything together. Then towards the end, I'll also cover when and how to start using orchestrators, how to evaluate if it's time for you to do that, for you to move on from whatever you're doing, how to evaluate orchestrators, and how to get started. So the data orchestration landscape is large. Shout out to Substack author Daniel Beach for this image that I shamelessly stole. Lots of tools on here. I'm not going to be going into any specific tooling so much. I might briefly mention a couple, but for the purposes of the demo, I'll be using Dagster, and lots of the screenshots will be from Dagster, but most of these apply to any orchestrator on the market. So what is data orchestration? Well, pulling from the GOATs, who wrote Fundamentals of Data Engineering, orchestration is the process of coordinating many jobs to run as quickly and efficiently as possible on a scheduled cadence. Good starting point for a definition, I think. It's, modern orchestrators have more capabilities than just coordinating tasks, and, the role of an orchestrator might not be to do so as quickly and as efficiently, but that's definitely what we strive for. To understand the value of orchestrators and why they're useful, let's consider a typical example, an ELT-L pipeline. So let's consider a marketing pipeline that at 8 a.m. extracts yesterday's sales data and loads it to the data warehouse. At 8:30 a.m., the pipeline transformed the data, making it suitable for downstream analysis. And then finally, we send the data to executives in an email, or we make it available to a dashboard, however we make this data available. Now let's discuss, this is a classic ELT pipeline with a little extra step at the end. So let's discuss implementing this with the simplest orchestrator there is, the tool called cron. Cron is the most basic kind of orchestrator. It's a tool that lets you schedule commands to run at specific times, real basic. So here's what this pipeline might look like as a cron job. You configure the time and task. So a little bit weird syntax, but this runs at 8 a.m. every day. The extract sales Python file, it can be any task or command that you want. At 8:30, we run a transformation script. This could be a Python file or a dbt run. And then finally, we send the data at 9 a.m. This could be Python. There are lots of other systems, but we'll keep it basic for now. We can use cron to run each step at a specific time. And now this is great for simple tasks. If there's not a lot to worry about and you are fairly confident in the timing of your tasks and there aren't too many steps, then this works great. It's simple and it's easy to use, but it doesn't scale or handle complexity very well. So let's dig into an example of where cron struggles. So imagine it's Black Friday, the biggest sales day of the year. And due to increased sales volume, the step where we extract data at 8 a.m. from our database with the previous day's sales, instead of taking 15 minutes like we expected to, it actually takes 2 hours because of the increased data volume. So then the extract step will still be running when the transform step is scheduled to start. It won't be complete. So what's going to happen now when the transform step runs while the first step is still being completed? Well, cron will run the transformation step when we scheduled it for on empty and incomplete data. And then after the transformed data, but it's empty or incomplete, after that runs at 9 o'clock, the executives get a report or an email showing $0 in sales because the transform step was transforming empty data or missing data. This leads to panic, confusion, and overall contributes to stakeholders' distrust of the data and your processes. Why does this happen? Cron isn't equipped to deal with situations where a task's runtime will continue into the next task's scheduled start time. So there's a problem because we can only statically set scheduling, and so when our extract step ran too long, it ruined all the later steps. So cron, very basic orchestrator, pretty inflexible. How can more modern orchestrators help us? Well, to start, orchestrators let you run steps when their upstream dependencies are complete. Instead of scheduling this to run at 8, transform to run at 8:30, etc. Instead, orchestrators will generate a DAG, a directed acyclic graph. Don't worry about it, but it's similar to what tools like DBT will do, where instead of initiating each step or command at a specific time, instead each task will wait for the upstream task to finish running. So the transform task won't run until the extract task is done, and sending data won't run until the transform task is done, regardless of timing. This is great. It makes everything sequential. So already one big benefit of using a modern orchestrator over cron is that we don't have to worry about timings and overlaps and things like that. In fact, orchestrators could even be configured to notify stakeholders if we see that the data is delayed, the extract step is taking too long, or the transform step is taking longer than expected. This is just the most basic example of how the modern orchestrators solve problems cron can't handle. There are some other benefits now that I'll get into, maybe a little bit early, but does anyone have any questions so far? I'll also address questions at the end. Great, I'll keep moving. Feel free to throw them in the chat. So what are the benefits of some of these more modern orchestrators like Dagster or Airflow or Prefect? Well, they support complex logic like conditional execution. So in this image, I hope it's big enough, we can see that there's a start task and an end task, and that end task will only run once both of its upstream dependencies, tasks A and B, finish running. In addition, you can have some even more complex logic like monitoring file systems for data to be dropped there, or like monitoring an FTP server, or waiting for new data in a database. It just lets us orchestrate and run tasks more dynamically. They also have nice GUIs to monitor pipelines. I hope this is big enough, but as opposed to a cron job, which is just some code and no GUI, modern orchestrators usually provide a quick way to assess the status and progress of your different pipelines and executions and workflows. Just getting into some of the other benefits now. Orchestrators provide simpler interfaces, simpler in quotes, because they can be complicated to set up at first. But it makes doing a lot of data engineering and workflow tasks a lot easier. Backfilling data, for example. Most orchestrators have features that let you backfill data. So, if you have to reload data, your source data has mistakes in it, or you're implementing new transformation logic and so have to reprocess your data, you need to backfill it. And that can be very annoying with cron, especially if the data volume is so huge that you can't do it all at once or it takes time. Most orchestrators will have features that let you do this more simply. You don't have to write tons of custom logic, and you can even backfill different days of data in parallel. Orchestrators make debugging a lot simpler, having, as I'll show you all later in the demo, having one place to check for logs as opposed to cron jobs which might not log at all, or they might log to different systems. Perhaps they do log to the same file, which is nice. Modern orchestrators often make it easier to debug these pipelines by putting the logs in one place. They also often natively support alerting. So if your workflow fails, if the extract task is taking too long or didn't complete, you can automate Slack alerts or emails or PagerDuty alerts, whatever, so that way you can stay on top of issues in your pipeline before your stakeholders come to you complaining. Then finally, for this section, often orchestrators will let you rerun subsets of pipelines. So you can imagine in the earlier example, perhaps the transformation step failed for some reason, maybe schema changes or too much data, whatever the issue is. With cron jobs, you have to wait for the next scheduled run and then it will run everything. Most orchestrators now, as I'll show you, let you rerun subsets of the pipeline. So instead of re-extracting the data, which you don't need to, the data that you've loaded is already good, you can just rerun the transformation steps and the step to send the report out. This saves time and makes it so that way you don't have to do redundant data loads and tasks. These orchestrators also often provide central control planes where you can do things like manage environment variables and configs. So, maybe you are updating connection information, login details for your Snowflake warehouse, or the path to a file system or FTP server. In big ETL pipelines with no orchestrator or no central control plane, you might find yourself updating these credentials or environment variables or configs in many different places, and it's very easy to forget them. We want to reduce the number of touch points needed or that get updated whenever we have to make a change. So having a central control plane is great for that and makes it much easier to deploy updates to configs. Also, just orchestrators often will contain all of the code across your pipelines and workflows. So you'll have your Python API calls that pull data in alongside or in the same repo as your dbt models and schemas. This is great for when you want to compare the two together. Maybe you're writing a new pipeline or updating a pipeline, adding new columns or changing schemas, new logic, etc. Being able to really quickly just in the same code base see like, oh, if I make this update in Python, then here are the places in dbt and my SQL files that I'll also need to make updates. I find it makes it a lot easier than alternating and going to different systems. These central control planes that usually, as you'll see, provide lineage. So if you are making an upstream update in a Python script or something, you're adding a column, it makes it very easy to see what all the downstream tasks or jobs that rely on this change are going to be, and makes it easier for you to then basically make the update everywhere that needs to, instead of like you make the update one place upstream, rerun everything, and it all breaks because you didn't understand that these dashboards downstream rely on the schema being a certain way, or the dbt jobs rely on that. So being able to get insight into that lineage is really useful and important. Finally, they also help you understand average runtimes of jobs and tasks. So maybe you have an SLA with your team or department where you need to make data available for analysis by 9 a.m. Well, if you don't know how long your tasks and job runs, how long your whole workflow takes, then it can be hard to schedule yourself enough time. When do you start the process if you don't know how long it will take? Orchestrators usually collect and make metadata available so that way you can see, oh, our ETL process typically takes an hour. So if we need to deliver data and we have an SLA of having this data ready by 9 a.m., then we need to start by 8 a.m. latest. So that way we have the full hour to run. These have just been some of the benefits of orchestrators. I will soon show y'all some pictures so you can, make the connection and see what this all looks like. But first, some takeaways of what we've talked about so far. Orchestrators schedule tasks and workflows. Cron is the most basic one, and it's great for simple tasks and a good starting point to automate your workflows, but it doesn't handle dependencies or delays or dynamic logic well. Modern orchestrators like Airflow and Dagster are more suited to handle these complex workflows. Next, I am going to show y'all a real pipeline, a demo that I have built. Now, I love going to live music. I love going to shows and concerts, but what I don't like is having to go to the website for each venue to scan and see if there are shows coming up that I'm interested in. If there are 10 venues that I like to see shows at, then I don't want to go to 10 different websites to check this out. So what I did instead is I used DLT, Data Load Tool, to make API calls to the Ticketmaster API, where now I just provide the venue IDs of the venues that I want to go to, and DLT will automatically load them all into one table. It also then loads the data to DuckDB conveniently. After that, I have some DBT models and jobs that transform the data. The Ticketmaster API gives you lots of extra columns and unnecessary information. And I just want to be able to look at one place, quickly see event name, venue, date, and a little bit of other information. So I use DBT to transform the data and cut down on the number of columns that I'm ultimately going to present in my gold or presentation layer. Finally, I use DuckDB to then load the transformed data from DBT to a Google Sheet. So that way it's easy for me to interface with. And I will now share my screen and show y'all what that looks like. Hopefully this will just work as is. So first I will show y'all, nope, not that. I need to do this. This is the end result. The Google Sheet concert calendar, my event name, the venue name, the date, time, and the URL to buy tickets, along with some other info, and this is just for debugging. So this is the end state now. In Dagster, the orchestrator that I used to build this, there are a few different parts, but this is basically, can people read this? Is it big enough on screen, or should I zoom in?
Yeah, this is good. Thanks.
Great. This is what the simple pipeline looks like in Dagster. We have, don't worry about this for now, we have the extract and load step that pulls data from the Ticketmaster API, two DBT models, a staging model, and then a gold layer model to transform that data, and then the final step where I load the data to Google Sheets. And now I can show y'all what these look like and why the interface is so nice. So first you can see easy lineage, as opposed to that cron example, which are just lines of code with the schedule and the command. It makes it really easy for me to see right away what are the different steps in my pipeline. Now this is very simple, but you can imagine for sprawling pipelines or large DBT projects, having the visual UI is really important and great. For understanding, I can see upstream and downstream assets, kind of how you might filter in a DBT project. And there are different parts to all this. So these are the assets. I can click into any of them. In fact, what I will do is I will just run these all now. And like I said, Dagster makes it really easy to check the progress because there's a central control plane where I can see all the runs. Oh, yikes. Okay, let me figure out how to make this look a little bit better. For Hopefully this is still visible enough. But you can see I kicked off the job, and in the GUI, I can, scroll bar is terrible, but you can see that, hopefully you can see if I can grab this little scroll bar here. Awesome. Stuff doesn't really work. Oh, there we go. You can see the different stages that I broke up the 3 different tasks that I have. Ticketmaster events, which could be named better. This is what is used to pull the data from the API. And then the Ticketmaster DBT model, which will run the transformations. You can see I get my logs right here as it starts to pull data from the different venues, Brooklyn Bowl, my favorite. And then the status of the load job. So I get these logs right next to the DBT log, which are about to kick off. And this is very simple, but it makes it really easy because instead of the cron situation where I'm like peeking into different files to understand what's happening, or they're running in the background, so maybe I don't even have access to the logs or the execution status. This makes it really easy to see what's going on. And this is just basic run information. This is finished now, and you can see here the usual DBT logs. And then finally, the last step is going to start. We can watch it happen where this data, the new data, is going to be reloaded and this full spreadsheet is going to be refreshed. Hopefully it happens in time away. Great. Okay, so I think I missed it. It was pretty fast. But every day I can schedule this to run, not worry about API rate limiting upstream when it comes to pulling the data, or if something goes wrong with the DBT model, then that's totally fine. It makes it easy to rerun this, and I have all the information available. In Dagster, these are all called assets. Assets are just any piece of data that gets written somewhere, like any process. You can think of them as like a task or the output of a task. So I have my DBT model as the event summary and the staging events. I have my DLT job that loads the data, and then finally the load events to Google Sheets job. And I get all this great information on the recent run statuses, descriptions. I'd have more metadata if I ran this more frequently. Lots of other information that's great for debugging and just understanding what is going on. I can have checks to make sure that things ran well. Quickly from this page, see the lineage upstream or downstream. I can see further upstream if I need to, etc. So really great control plane to just see all the information. And I haven't yet, but I can schedule this whole process to run by creating a job, which is just a series of tasks that are put together. For convenience, I have a few here. I have my full pipeline job, which does the full ELT and then load back to Google Sheets. Or if I only am testing logic or want to rerun the transformation job and downstream, so like I don't want to get rate limited by the API, I can run this job whenever I want, and it will show me the assets that are going to be materialized, and then I can really easily I run this, then I just export it, and I can iterate really quickly if I need to make DBT model updates or change where I want to export the data. Finally, if I'm just testing the export, maybe I want to write to a new Google Sheet or a new format, play with some configs, I can just run this asset by itself. I've created a job for convenience, but you don't need that. It's very easy to put these on a schedule like a cron job. And what's great is, like I said, I only need to schedule the start of the job. I don't need to worry about overlapping tasks, interrupting or overlapping with the following task. Everything runs in order when the previous job is complete. So Dagster is great for that. I can really quickly log in and see the run status for all my jobs. Love it. Green is good, red is bad. This makes it very easy to quickly understand what happened, how long my runs took, what got ran. And I think it might take a little bit long now, but what I can even do is I can show you what happens when I materialize or run a job, and then what happens when part of this DAG fails. Remember, in the other example, we might have to go back and like manually run a script, rerun a transformation script, wait for that to be done, and then run the script to send out all the data, or I might even have to just wait and re-pull all the API data if one part of this process breaks. As you'll see here, though, what I can do, I'm going to induce a failure in this next step and cancel it in the middle, and then show you how I can really easily in Dagster just like pick it back up and rerun only from the point of failure instead of the whole thing. Nice, that's running, that's completed now. I'm just gonna terminate this right now to induce a failure that could be from whatever thing. And now, right, it's terminating or figuring out how to do that before it starts the job. Great. Hopefully, right, cool, we get this one error, the job is gonna cancel. And now what I can do when this job fails is I can just rerun it from the failure, skipping the steps that completed. I can run it specifically like from the asset that did fail. So I'll just hit run from asset failure, and now you can see it's only starting from the job that failed instead of rerunning that DLT API extract step. Great, very convenient, makes it easy to run jobs, understand the status of my pipelines. If something goes wrong or my data looks incorrect, I can really easily go to the asset lineage and understand for any given piece of data or dashboard what came upstream. If someone's looking at the Google Sheet and they see the formatting is way off, instead of having to wonder what DBT models are upstream of this, where the error could have come from, and go through scripts and look at function references, etc. Dagster, Airflow, all these orchestrators make it really easy to see what's upstream. That basically concludes the demo part of this, and you'll see here that in the run history, it's running every time I told it to and reloading the data. Yeah, this is great. I can now check this every day, and if I'm bored one night or want to make plans or see if my favorite bands are in town, I just have to check one spreadsheet instead of 10 different venue websites every day. Awesome. Now, bringing it back. So I've talked a lot about orchestrators and why they're useful and the problems they solve and shown what you look like. Now, actually, before I get more into it, any questions on what we've seen that I can answer, or we can wait till the end? Feel free to raise a hand. I'll wait, give it a few seconds.
Avishua, I just jumped in on the chat. Somebody asked a question about Dagster as a replacement for DBT Cloud, but maybe you could just address that quickly before the demo.
Yeah, so I didn't spell this out, or maybe I did briefly, but DBT is a type of orchestrator, except instead of orchestrating Python jobs and the whole pipeline, the whole workflow, it only schedules DBT jobs. So your question is, Dagster, it tells DBT when to run its job. Does this mean that one does not need to create a scheduled job in DBT like in DBT Cloud? That is correct, because instead of using DBT Cloud as the scheduler and orchestrator, instead we are using Dagster. So that's totally correct. And what's great is that instead of, maybe you have a 5-tran process that loads data on a schedule, like I said before, instead of waiting or hoping that your scheduled DBT job runs when your data is already available, by using an orchestrator to control all parts of the workflow, we just, we set one schedule to start and pull the data, or to check if the new 5-tran data has been loaded to Snowflake, and it will automatically run your DBT jobs. You can even get fancy and do it dynamically. If you are waiting for one source of data and it arrives, instead of rerunning every DBT job and every model, instead what you can do is you can dynamically have Dagster look and say, like, okay, this Google Ads data is ready. Don't rerun everything, only rerun the tagged models or these specific models, or a job that you define where you reprocess or transform the Google Ads data, not your data from every other source. If that is all, I will continue for now. So pipeline demo, I've talked about orchestrators, why they're good. how they're useful and how modern orchestrators take over and fix the shortcomings of just using cron. Now I want to briefly talk about the downsides of orchestrators, and there aren't many bullet points here, but they are significant. So the first downside of using a modern orchestrator is that they're complex to set up and maintain, and they require more infra and engineers. So like any new software that you're thinking about adding to your stack, there is a cost to adding an orchestrator, and it's not always worth it. And I'll get into that in the next slide. But it's new infrastructure. You need to find a place to run this, because orchestrators like to run 24/7, so that way, whenever any job scheduled for any time of day is ready to go and it's time, the orchestrator can kick that off. Or it can constantly monitor for new data if you're dynamically triggering your workflows from data being dropped into an FTP server or an S3 bucket. But you have to, if you're only using dbt Cloud, for example, or Lambda functions in AWS, then you don't have to worry as much about infra. But for this, you need to spin out a long-running virtual machine like an EC2 instance. You need some Python knowledge. So if you're a SQL-only shop, then it might be hard to get into using orchestrators and all the Python coding that you have to do. Not impossible, but you need to make sure that you have the engineering hours and the infrastructure to run this, although I'll talk about some exceptions in a little bit. So the downsides of orchestrations and orchestrators is that they're complicated, they add more complexity. I can't just do dbt run or click a button and have it all be set up. It does take time. But now let's talk about when to start using orchestrators and orchestration. So ask yourself some of these questions to determine if it's time. How much time do I spend manually coordinating, debugging, and monitoring data jobs? I want people to understand that, like I said, orchestrators are difficult, and if you don't need one, don't use it. There are always shiny new tools, and I think for engineers or many folks who love learning new things and understanding new technologies and just making things be really cool, or you want to look good, things to look good on your resume and write that you have orchestration experience, just first consider the reality of your data situation. If you don't have many pipelines and you don't really struggle with debugging or maintaining them, then you probably don't need an orchestrator. Maybe some good Python automation will help. There are intermediates between just straight cron jobs and Airflow or Dagster. So unless you need that central control plane and you have more complex workflows that require dynamic or more involved logic to schedule and kick off jobs, maybe look into some other options first. Ask yourself if your data pipelines are spread across multiple systems or tools, which makes it hard to manage. Like I said, orchestrators provide a central control plane, but if all of your pipelines are just like a few Python scripts in a single mono repo, also containing your dbt repo, or if all the code you need for your pipelines and workflows are in one place, then they're already centralized. A central control plane might not add that much value, as opposed to if you have some teams manage these processes, or you have like Kafka pipelines written in Java and Python pipelines and SQL pipelines, all these things written across different repositories or locations, or maybe not in any repository at all, then that might be a good time to centralize and use an orchestrator to put them all in one place. Ask yourself, kind of related to the first one, like how frequently are you troubleshooting missing or incorrect data in dashboards? Is it, do stakeholders come to you saying these numbers look off, they don't match the Google Sheet that has been manually had data input into it since the beginning of the company? If you frequently get asked that question and you're wondering why your dashboards look off or something like that, and you don't have visibility upstream, you don't know where this data is coming from, what the code is, what the SQL is, what the models are that generate this data, then having a tool that provides lineage, orchestrator, or otherwise could be a really good investment to get visibility and understand where this data comes from, and just save yourself time digging through random files and desperately slacking the engineer who has left that project 2 years ago being like, hey, where does this data come from? And then you also have to ask yourself if your team has the resources in terms of like time and knowledge and technical know-how and infrastructure to implement and maintain it in Orchestrator. They're complicated, and sometimes even if an orchestrator would provide a ton of value, it's just not worth the trade-offs. Maybe you don't have the budget to implement one, or no one knows Python. And so it could shake out and on the whole end up not being a wise or worthy investment. Oftentimes, setting up an orchestrator or any new piece of infrastructure and software means that you don't have as much time in the near medium term to add value by working on pipelines and understanding the stakeholders' needs and delivering data and value. But on the other hand, if you do have engineers and you do have time, there isn't a ton of urgency for the next features that you plan on building out, and you're resourceful and you can get the infra for it, then yeah, maybe an orchestrator is worth it and shakes out to be more valuable than not having one. So having talked now about when to start using orchestration and the questions to ask yourself, let's get more into how to get started. So the first part is when you're picking an orchestrator, there are tons out there. If you recall the image I showed with like 15 different tools or whatever, lots of orchestrators out there. And other folks have written about criteria for picking them. I'll touch on a little bit of that, and then I can direct folks to more resources later. But consider the following. What's the size of the community? Do they have a good, do they have forums, or do they have a Slack community? A larger community and more users typically means that there are greater learning opportunities, either because there are more tutorials or documentation, or you can join the massive DBT Slack and Google that error or that bug that you got, and you're more likely to find others who have had that problem and found a solution, or at least maybe people to commiserate with. Larger communities mean larger support, and this is true of any new tool that you're evaluating, not just orchestrators, but given the complexity of orchestrators, it's a salient point really worth keeping in mind. So if this orchestrator looks really cool, maybe maybe like a salesperson from an orchestrator hits you up and being like, we will solve all of your problems with this orchestrator. It's turnkey, white glove, just press a button and you're good to go. Be skeptical, salespeople, but do some looking. And if their orchestrator has an open GitHub repo with 5 or fewer stars, then it might be really cool technology and could be powerful. But before you invest all this time in trying to learn it, consider that like you won't have that many people to go to if you need help. So often larger community, especially a larger community of dedicated folks, is better for learning and resources. Next, make sure that it integrates with your existing stack. Some people have loosely defined stacks that are just Python scripts and SQL files. In that case, most orchestrators will probably be able to integrate with those. But if you're using DBT or DLT or any other fancy framework or tool, it's worth checking to make sure that the orchestrator that you are looking at has a native integration, because orchestrators are complicated. And part of the point is that in using an orchestrator, you are signing yourself up for a framework that should make your life easier and reduce the amount of boilerplate code that you need to get everything working. Most orchestrators have an integration page. I will show you Daxter's in just a little bit, where you can search for DBT or Snowflake and see that they already have connectors for these common parts of the tech stack, of the modern data stack. But always worth checking. Then you'll have to consider the infra side of things. How do you deploy and run and maintain the solution? Can it be self-hosted? At Wikimedia, for example, we have strict privacy requirements where we self-host pretty much our entire stack. And so it had to be, some orchestrators only run on the cloud, and those were non-starters for us. It has to be self-hosted. If your team, for example, already uses like Docker to deploy pipelines and infrastructure, then check that the orchestrator you're evaluating has a pre-built Docker compose file, or if you're on Kubernetes, make sure they have like a Helm chart. to just make it easier to stand it up and get things running. For many people, this won't be a problem. Their stacks are flexible, or they're not opinionated about how they host and deploy and maintain services. But for the rest of y'all, it's important to consider. And on the other end of that too, I want to talk about managed services like DBT Cloud, for example, is in a real sense a managed orchestration service compared to DBT Core. Maybe you see that you would get a ton of value out of using an orchestrator. You want the lineage, and you want the GUI, and you want just an easy way to understand what jobs run when and to connect them together. The central control plane and central logging sounds really useful and valuable, and will save you time and money. But you don't have the infra or the engineering resources to stand up and host this on your own. Like, you don't know how to dig in and set up Docker on an EC2 instance or on ECS or whatever cloud service you provide. Most of these orchestrators, especially the open source, open core ones, they got to make money. So they're going to have a managed service where instead of you having to host a machine to run this on and maintain and deal with software updates, you can usually just pay them to do it. And if you have more money than engineering resources, this is often a good route to go. You can talk to the folks at the orchestration company and tool about SLAs for support. Like, will they help you only do an initial setup? Will they help you upgrade the software? Do you have a direct line of communication when you run into bugs? Oftentimes it's worth paying $30K to an orchestration company to manage that infra instead of like $150K to hire a data or site reliability engineer to maintain that for you. Great. I've talked a little bit about how to evaluate and pick an orchestrator, how to know when it's time. Say now that you have gotten to the point where you're like, I want to at least investigate or try and get my hands dirty with an orchestrator. How do I start? Some high-level guidelines. Start simple with a single pipeline or task. Maybe you want to evaluate Dagster. Go to their docs, go to their installation page. They'll usually have a hello world example of sorts that you can just git clone, or maybe a cloud service where you just like sign up, put your email in, create an account, and it will get you started immediately. But start simple. You don't want to be evaluating multiple new technologies at once. It makes it much more difficult to properly evaluate and disentangle the trade-offs between them. If, for example, you are, I don't know, maybe you have some like Java ETL pipelines that you want to move to Python at the same time that you're looking into an orchestrator, and also you've heard about this cool tool DBT that you want to check out. Don't try and implement these all at one time if they're all unfamiliar to you. It makes it more complex. So start with maybe just first move that Java pipeline that's hard to debug and understand to Python. And then once you're done with that, try getting it to run in an orchestrator. Get your hello world to run and take the technologies one at a time first. Then maybe you've decided you've done some work and you've seen this was easy enough to set up. I can see myself using this tool more. Try running, you pick a pipeline that you want to migrate and try and run that same pipeline with your existing setup, be it cron job or manually. And also alongside it, run that same pipeline in the orchestrator. Maybe just have it write to a different dev or orchestrator schema separate, where you can then do some diffing and compare the results. It's easy for seemingly simple pipelines to have parts that are lost in translation. And so it's really important, of course, when you're doing any migration, not only orchestrate migrations to an orchestrator, but to any new tool, like from raw SQL to DBT, you got to compare the outputs. And maybe, oftentimes you'll find that actually the orchestrator solves some problems for you that and resolves discrepancies that you didn't even know existed. But start simple and do some comparison. If you are motivated to or are able to do this outside of your day job, maybe your work doesn't need an orchestrator, but you are interested still, do what I did. Pick a fun side project, maybe even a useful one like this concert calendar I built. If you need help thinking of ideas, hit me up after this. My brain cannot stop generating them. But pick a side project to try out first before you decide to move your company's legacy tech stack to a fancy new platform. Then this is more just on general resourcefulness for orchestrators or other tools. Join their Slack community. Connect with some of the folks on LinkedIn, perhaps, who work at this company or who appear to be experts. Or engage with a company like Database Tycoon. They didn't ask me to sell that, but they offer great services and have expertise in many of these. Find a place where you can ask questions. You want to learn, you want to understand pitfalls, you want to understand best practices. And the best way to learn that, if you don't have a senior engineer who's already deeply familiar and has expertise in a tool, you don't have them sitting right next to you, joining a Slack community can be the next best thing. As an example or an aside, we started using Trino, and I needed and still need some help setting it up and understanding some stuff or fixing this bug. I posted in the Trino Slack, and well, the first response wasn't super helpful, but the second one was great. This person's like, oh, we can implement this iceberg spec format into Trino. And a few weeks later, they had the PR opened, written, and merged, and our problem was solved. It was really useful. So join the Slack community, engage with users of these tools. And then finally, AI is crazy now. They can code fairly well. Use it responsibly to debug. If you get an error trying to set up an orchestrator, first search Google or Slack perhaps. Ultimately, you want to develop the understanding, but if you're not finding the information that you need, it doesn't hurt to use AI and ask it a question. I know some sites like the Dagster documentation website, they have a built-in AI. DBT also has this, for example. And they're not perfect. No AI is, hence the use responsibly part. But they're still really valuable resources if you're just like, man, I need to figure out how to set one task as the upstream dependency of another task. Digging through docs and trying to figure out yourself is helpful for a lot of reasons, but maybe just need to get something figured out quickly. Ask AI, and hopefully it'll put you on the right path. Those are my tips for getting started. Just some key high-level takeaways from this presentation. Orchestrators are great. They help us run complex workflows. Cron is useful and a good starting point, and in some ways the OG, most simple version of an orchestrator, but modern orchestrators are more powerful, more complex, but come with lots of features that make up for Cron's shortcomings. Start it when the manual coordination becomes painful, and when the pain points are too great and and are highly acute. Don't do it for nothing. If you can get away with manual coordination or cron jobs, then keep it simple for as long as you can. Finally, evaluate carefully and vigilantly. Choose the tools that fit your team, your tech stack, and your infrastructure and your requirements. That is my presentation, y'all. Thank you so much. I can now take questions. Right. I realized I forgot to dig in some of the code. Stephen, let me know if you want me to hop in there real quick.
I just wanted to put a note to you that you can either raise your hand to speak and ask a question, or you can just write it in the chat.
I'll jump in because I was trying to keep an eye on the chat messages as they were coming through, and there was a follow-up question about what can be included in a pipeline. So in addition to just running DBT, Avishua, is it true that you can also just continue to add other assets, other dependencies downstream, like tests and alerts and reporting?
Yes, if I'm understanding correctly. Yes, you can add more tests and alerting downstream or upstream of any process. That's part of why it's so flexible and powerful. So, if you want to check your data before it gets to DBT or in a downstream process from DBT, you can, I think there are lots of code libraries that can do so. I think a lot of orchestrators also have built-in checking and data quality features too. And, you can always just add a new, we had our pipelines built, And only after that was mostly set up did I add Slack alerts and notifications. So you can always go in and edit existing flows and pipelines and add new tooling or capabilities to it. It doesn't have to be linear or sequential.
Nice. Yeah, I think it really shows one of the true advantages of orchestrators, which is if you take the time up front to set it up and get it running, the orchestrator itself, then you can really go all in with all of your other platforms to the extent that they're supported, right? Like you can start looking at all of your expensive cloud subscriptions perhaps and start thinking, you know, which of these do I truly need or which can just be brought into this one project.
Exactly.
But anyway, yeah, any other questions from anyone here?
Let's see. Can you recommend sample code or tutorials on GitHub? Yes, totally. So for Dagster specifically, because that's what I've worked with recently, they have Dagster University, which is great for getting started. You know, they have a repo that you can clone. I think most of these tools do have like the getting started hello world repo. And then usually with some I'll speak about Dagster because that's the one that I have the most experience with as of late. In addition to Dagster University, I was trying to figure out how to set up DLT, the data load tool, with actually let me just stop sharing real quick. With Dagster and how to integrate it. And so on the docs page for the Dagster DLT integration, they had a repo, they had a little tutorial to set up. So specific ones, hit me up after and I can probably generate a wider list, but I think Dagster University is a good start. Certainly you'll find Airflow ones too, the more popular. Like I said, the bigger the community, the more likely you are to find resources for learning. Yeah, the Dagster one's great. Anything else that did not get touched or answered? Okay, I think we're pretty good there, unless more folks have more questions, which I'm happy to answer. Stephen, if you want, we can call it, or I can briefly go into some of the code behind my demo pipeline. I just forgot to add the note in to switch to that part.
Yeah, unfortunately, I don't think we're going to have time for that today, but maybe that's a good reason to do a follow-up someday.
Definitely. And I have to clean it up a little bit, but I will also make the repo for this Dagster project available on GitHub so you can poke around and see how it's all set up, or clone it if you want your own concert calendar.
Amazing. Well, as someone who also lives in New York, I would definitely like to use it. So thanks for showing us your example. And thanks for your presentation in general. That was really great.
Of course. Thanks for having me and happy to share knowledge. Looking forward to more of these and talking to folks and learning and helping others learn.
Sounds good. All right, to wrap it up, I'll just close things out and say, you know, Database Tycoon is, I guess, 2/3 of the way through this summer camp now. We have a few more sessions coming up in August. If you are in this meeting, it means you have signed up already and you're getting the invites. So please continue to join and yeah, keep Database Tycoon in mind if you run into any data challenges on your own team. We're a full service data consultancy. We work with orchestrators and we work with all the other parts of the data stack as well. And we have lots of opinions about, you know, how we can use these tools to improve your day-to-day life in your job and improve team dynamics and all those great things. So please reach out if you have any questions, and yeah, hope to see you in a future week.